The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. Yes. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, today we're going to go on and take a look at section 7.6. And so let's get started. If we have a fraction, let's say 3/7, we can multiply the numerator and the denominator by the same non-zero number because a number divided by itself other than 0 divided by 0 is equal to 1. And we can multiply times 1. So therefore we can multiply the top and the bottom of a fraction by the same non-zero number. Let's say we have an equation like this. 7/4 equals x over 8 plus 5/2. We can multiply both sides of an equation by the same non-zero number as well. If we in fact choose a special number to multiply by, nice things happen. That special number is the least common denominator of all the little denominators. So what have we got? We've got a 4 and an 8 and a 2. So the least common denominator of 4, 8, and 2 is 8. Are we okay with that?
Yes.
So what we're going to do is we're going to multiply both sides of the equation by 8, or 8/1. So on the left side, the 8/4 reduces to 2/1 and we get 14. On the right side, we've got x over 8 times 8/1. The 8's reduce and we have x. And then 5/2 times 8/1. The 8/2 reduces to 5/1 and we have plus 20. So distributing the 8 here, here, and here, we get rid of all the denominators and we have this equation. Any questions about what I did there? All right, now going on and solving the equation, I'll subtract 20 from both sides and I get a final answer of x equals -6. So we all right with that?
Yes.
So that's the basic idea in this section. Let's continue with some perhaps less friendly problems. How about this one? 3/4h plus 2/h equals 1. So the least common denominator here would be 4 times h. So I'm going to multiply both, hold on here. Both sides by 4h or 4h/1. Okay. So distributing here, 4h/1 times 3/4h. The 4h is reduced and we have 3 plus 4h/1 times 2/h. The h is reduced and we have plus 8 equals, on the right side, 4h. So now we have what? 11 equals 4h. Divide both sides by 4 and h equals 11/4. Just a reminder, WebAssign doesn't like mixed numbers, so you'd want to put an improper fraction as an answer rather than what 2 3/4. Okay. Another example. How about this one? 1/14 plus 2/n minus 2/21 equals 0. The least common denominator here would be 42n. Does anybody want me to go through the process of how I got that? Okay.
Yes, please.
Yes, please. I can do that. All right. So 14 is 2 times 7. 21 is 3 times 7. So you need the highest power of each different prime factor. And you've also got what? N. So there's your 6 times 7 in 42 n. So from here we get that. From here we get that, which leads us to this. We okay with that, Abel?
Yeah.
All righty. So now I'm going to multiply both sides by 42 n. So 42 n times 1 over 14. 42 over 14 is 3, so I get 3n plus 42 n times 2 over n. 42 n times 2 over n. The n's reduced, and I get plus what? 84, and then minus 42n times 2 over 21. 42 over 21 is 2 over 1, so minus 4n equals 0 times 42n is 0. Okay. Combining like terms, negative n plus 84 equals 0. Adding n to both sides, 84 equals n. And there is your final answer. Any questions there? All righty. Let's take a look at this problem. D equals 4 plus 21 divided by D. Now, the least common denominator here, keep in mind there's implied ones there. 1 times 1 times D, so the least common denominator is just D. Okay, so we're going to multiply both sides by just D. On the left side, I get D squared. On the right side, 4 times D is 4D plus 21 over D times D over 1 is 21. So we get that. Now, this is a second degree equation. So let's move everything to the left so that we have a leading coefficient that's positive. So I've got D squared minus 4D minus 21 equals 0. Okay. That's going to factor into D minus 7, D plus 3. So D minus 7 equals 0, add 7 to both sides, D equals 7. D plus 3 equals 0, subtract 3 from both sides, D equals negative 3. So it looks like we've got two solutions. Well, let's check our work. Let's rewrite this equation on the next page. D equals 4 plus 21 over D. Let's see, is that correct? Yes. And we got 7 and negative 3. So D equals 7, D equals negative 3. Let's check our work. If D is 7, we'd have 7 equals 4 plus 21 over 7. 7 equals 4 plus 3. 7 equals 7. So that one checks. If D is negative 3, we'd have negative 3 equals 4 plus 21 over negative 3. Which is negative 3 equals 4 minus 7. Negative 3 equals negative 3. And that one checks. So both solutions check. Any question about that problem? Okay, let's take a look at this equation. A squared over A plus 2 minus A equals 4 over A plus 2. So the LCD here is A plus 2. Is everybody okay with that? All right, so we're going to multiply both sides by A plus 2. On the left side, I've got a plus 2 times a squared over a plus 2, which is going to be a squared, and then minus a plus 2 times a, which would be minus a squared minus 2a. Okay. In fact, here, let's do this. Let's do that in 2 steps. So it'd be minus, and then this would be a squared plus 2a. So then distributing the negative sign or the subtraction sign, you get that. And on the right side, you're going to get 4. Okay. Now, combining like terms, those would cancel. Negative 2a equals 4. Divide both sides by negative 2, and a equals negative 2. Now, you might think that everything's fine, we're done, and we can move on. However, what happens if I take that and I check my work in the problem? Okay, let's go back and let's rewrite the original problem. A squared over a plus 2. Let's see here, where did I get this one? Minus a equals 4 over a plus 2. And we said a is negative 2. If I put negative 2 in the place of a, I've got a big problem right here and right here. What's negative 2 plus 2? It's 0. So we're dividing by 0, which is undefined. So that means that a does not equal negative 2. So we would say no solution. Now, there's something called an extraneous EOUS solution. An extraneous solution is a solution that you arrive at, but when you check it, it doesn't work. Not because you made a mistake, but because you actually broke a rule, and we'll talk about that. So we would say negative 2 is an extraneous solution, and therefore there is no solution. Okay, what's legal? You can multiply or divide both sides of an equation by the same non-zero number. You cannot multiply or divide both sides of an equation by 0. That's an illegal move. You can't divide by 0 because that's undefined. And if you multiply both sides by 0, you get 0 equals 0, which is true, but you haven't solved the equation. You basically eliminated it. Consider this. If a is negative 2, then negative 2 plus 2 is 0. We multiplied both sides of the equation by 0. So I broke the rules, but I didn't know it at the time. How did I determine that? Well, in the end, checking my work, I was able to determine that it wasn't going to work. Okay, so bottom line here, check your work. Make sure that you don't come up with an answer that's extraneous and therefore it doesn't work. Okay, let's see here. Let's take a look at this problem. X plus 6 over x plus 4 plus 1 over x squared plus x minus 12 equals 1. All right. So to find the LCD, I'm going to factor each denominator further if I need to. What I would get is x plus 6 over x plus 4, 1 over x plus 4, x minus 3. Okay, so this factors into x plus 4, x minus 3. So my LCD is x plus 4 times x minus 3. Okay, so now I'm going to multiply both sides by x plus 4 times x minus 3. X plus 4 times x minus 3. Distributing here, I get x plus 4 times x minus 3 times x plus 6 over x plus 4. What's going to happen there? The x plus 4s are going to reduce down, and I'm going to have x minus 3 times x plus 6, which is x squared plus 6x minus 3x minus 18, which is x squared plus 3x minus 18. Then I'm going to
Can
go.
you slow down just a little bit?
Absolutely. This startled me. I'd fallen asleep. Absolutely. Let's write that. That's a 6. There's a lot of writing, but all that really was going on was the x plus 4s were getting reduced out. And
Okay, as I was like, wait, you confused me. Let me backtrack real quick.
yeah, so the x plus 4s went away, and then I took this and foiled it out to get this down here.
All right, got it.
Okay, now all of this, whoops. All of this times all of that, I've got x plus 4 times x minus 3 times 1 over x plus 4 times x minus 3, which is plus 1. Okay. Oh, that goes, because this went and this went. Okay with that?
Yes.
Over here, 1 times x plus 4 times x minus 3 is just x plus 4 times x minus 3, which is x squared minus 3x plus 4x minus 12, which is x squared plus x minus 12.
Okay.
Combining like terms, x squared plus 3x minus 17 equals x squared plus x minus 12. I'm going to take this and copy it on the next page in just a minute here. X squared plus 3x minus 17 equals x squared plus x minus 12. Are we done with this page, or do I need to leave it up there longer?
I'm done.
All right, so now let's see, I'm going to subtract x squared from both sides. So now I've got 3x minus 17 equals x minus 12. So now it's no longer a second degree equation. It's just a first degree equation. So let's put all the x's on one side. I'll subtract x from both sides. And all the constants on the other side, I'll add 17 to both sides. Divide by 2 and x equals 5 halves. All right.
That's 5, 2. 2x equals 5, 2.
5 over 2, 5 halves. Or 2.5. But again, remember in WebAssign, you don't want to use mixed numbers.
Yeah.
Because so now this would reduce down. Now let's check our work. 5 halves. Let's go back up here. What would cause problems? Well, a -4 would give us a 0 in the denominator there. 5 halves is not -4. Same thing here. A -4 would give us problems there, but it's not. A +3 would give us problems there, but the answer is not +3 or -4. It's 5 halves. So this should be an answer that works. All right.
Yes. Okay.
Okay, now we're going to look at some formulas, and we're going to solve the formulas for the given variable. So T equals 3 capital R over capital M minus N, and solve for R. Now, a couple of things I need to tell you. First of all, in a formula, a capital letter and its equivalent lowercase letter are not the same. So a capital R and a lowercase r aren't the same. In WebAssign, let's say you've got this problem, but in your answer, you write R as a lowercase r. It doesn't matter what else you do, it's going to mark it wrong. So don't change the case of the variables in the formulas. All right. And this is true for other problems as well. I've had students that they had a problem like this, but they used a capital X instead of a lowercase x, and so it marked it wrong. So get used to keeping the same case. All right. So back to this. I'm going to solve for capital R. Well, I'm going to clear the fractions. So I'm going to multiply both sides by big M minus little n. So that would get rid of those. So I've got what? Big M minus n times t equals 3r. I'm going to divide both sides by 3. So capital R is m minus n all times t over 3. And you could leave it that way, or you could distribute the t if you wanted to. Whoops, that was weird. Okay. So either one of those would be correct.
Okay.
All right. Any questions there? So or that. We good to go on?
Yes.
Yes.
Okay. S over K plus H equals E. We are to solve for K. So K is in the denominator, so I need to get it in the numerator. So let's again multiply both sides by K plus H. So now I get S equals E times K plus H. Now, I've got a choice. I've got two different ways I can go. One might work, the other might not, or they might both work. I need to get K by itself. I can't subtract H from inside of there. So the question is, do I divide both sides by E and then subtract H from both sides, or do I distribute first and then deal with it? You can go either way. So do you want me to distribute the E or not?
I say we divide by E.
Okay, all right, let's divide both
You want
sides.
to do
by-
both?
Yeah, sure. And no extra charge to you. So I get S over E equals K plus H. So now I'm going to subtract H from both sides. I'll be careful. So I've got S over E minus H equals K. This minus H is not over E. It's just by itself. Okay, so that's one correct answer. Now let's go back to here. And let's distribute instead and see how that comes out. So here, my next move would be to subtract EH from both sides. So S minus EH equals EK. And then I'll divide both sides by E. So K equals S minus EH over E. Now, let me convince you that these two are the same. Okay. If I took this and I wrote it as two separate fractions, it would be S over E minus EH over E. And then I could reduce out the E's and I'd have S over E minus H, which is right there. So they're both correct answers. All right with that?
Yes.
Everybody else? Okay, good. All right, what about this one? Two over C plus 2 over D equals 1 over H. Solve for C. Well, C is in the denominator and I need it in the numerator. So the first thing I'm going to do is multiply both sides by the LCD, which is CDH. Okay. So distribute, multiply. CDH times 2 over C plus CDH times 2 over D equals CDH times 1 over H. So that's distributing, okay?
Mhm.
Come back and reduce, we'll reduce out the C's, the D's, the H's. I've got 2DH plus 2CH equals CD. Now, we're trying to solve for C. I have 3 terms in the equation. 2 of them contain C. So let's get the terms with C on the same side of the equation. So I'm going to subtract 2CH from both sides. Okay, let's see what that does. So the 2 terms that contain C are together on the same side of the equation. Now comes the trick, if you will, to this problem. We're going to factor out the C from both terms on the right side of the equation. What that allows us to do is to divide both sides by what's remaining, and we've solved for C. 2DH over D minus 2H equals C. So what did we do? We cleared the fractions. We got all the terms with the variable C on the same side of the equation. We couldn't combine them, but we could factor the C out of them and then divide both sides by what was left. How we doing?
Think okay.
That one
I
was,
got confused. I got confused a bit at the very end of the that one. Yes.
so are you okay to there?
Yes.
All
So I'm
right.
gonna minus the D. You said we were gonna put them together. Yeah. So that
Okay, what are we gonna do here? We're gonna factor the C out of both terms, which leaves us with D minus 2H inside.
yeah.
Then we're gonna divide both sides by that D minus 2H.
Okay.
That will reduce it down and we'll have C equals 2DH over D minus 2H.
I have a question.
Yeah,
Since you're factoring out 2 C's, wouldn't that be C squared?
okay. Let me ask you this. What's the greatest common factor?
16.
4?
4. So you'd factor, whoops. You'd factor out a 4, right?
Mhm.
Or would it be 4 squared?
Just a 4.
Exactly.
Could you distribute it to 4?
So it's just a C.
Okay.
You see it? Same thing?
Yeah.
Okay. Let's do another one of those. Let's see here. 1 over A minus 1 over B equals 1. Solve for B. So the LCD in this case is AB. All right. So we're going to distribute AB times 1 over A minus AB times 1 over B equals 1 times AB. AB times 1 over A, the A's reduce out and we have B. Minus AB times 1 over B, the B's reduce out and we have A. Equals 1AB, which is AB. So far, so good?
Yes.
All right. But we're solving for B. So let's get all of the B's. Actually, you know what? Let's do it this way. Well, no. We'll do that. We'll subtract B from both sides. Okay. I've got negative A equals AB minus B. Okay. I'm going to factor a B out of the right-hand side. Then I'm going to divide both sides by that A minus 1. So B equals negative A over A minus 1. Basically, it's the same problem, only there's only 3 terms instead of 4, only 2 variables instead of 3. So it's a little less to deal with, but it's the same idea. Distribute the LCD, get all the terms with the variable we're trying to solve for together, factor that out from the stuff that's left, divide both sides by the stuff that's left. That being the A minus 1. We okay with this one?
Yes.
Karina, Abel, you seeing it?
Yes, I am.
Yes.
Okay. How about this one? F over M equals A. Solve for F. Well, if we multiply both sides by M, we get F equals AM. That they were all that easy, right? Okay. We good to go on?
Yes.
Yes.
EC over S equals T over R. Solve for C. Well, we could multiply both sides by S. On the left, the S's would reduce out, giving us PC. And on the right, we'd have ST divided by R. Now I can come back and divide both sides by P, or I'm going to multiply both sides by 1 over P. And the reason I did that is because that makes it easier to see that over on the right side, the P is in the denominator. If instead I said divide both sides by P, then you'd have to deal with this, and you've got ST over R divided by P, which is ST over R times 1 over P, which R, which gets you there eventually. So that's why I multiplied by the reciprocal instead of just dividing by it. Is that making any sense?
Yes.
Okay. We good with that one?
Yes.
All right. Let's take a look at this one. N divided by n squared minus 9 plus n plus 8 over n plus 3 equals n minus 8 over n minus 3. Well, if we factor that first denominator, the difference of 2 squares, we get that. So now the LCD is going to be what? N plus 3 times n minus 3. Okay. So we're going to multiply both sides of the equation by n plus 3, n minus 3, n plus 3, n minus 3. Distribute, distribute, multiply. So I've got n plus 3 times n minus 3 times n over n plus 3 times n minus 3. Let's make that a little bit smaller. Plus n plus 3 times n minus 3 times n plus 8 over n plus 3 equals n minus 8 times n minus 3 or over n minus 3 times n plus 3 n minus 3. Put these in there just to remind you where things are. Okay, let me know when you're ready to go to the next step.
Ready.
Everybody else ready?
Ready.
Okay, so this is going to reduce out, giving us n plus this is going to reduce out, giving us n minus 3 times n plus 8. And this is going to reduce out, giving us n minus 8 times n plus 3. Which gives us n plus n squared plus 8n minus 3n minus 24 equals n squared plus 3n minus 8n minus 24. Let me know when you're ready to go on.
Ready.
Combining like terms on the left side of the equation, we get n squared plus 6n. 1n plus 8n is 9n minus 3n is 6n minus 24. On the right side, n squared minus 5n minus 24. At this point, it's a second degree equation. I'm going to put everything on the left. So I'll start by subtracting n squared from both sides. But when I do that, I see that The n squareds cancel. And now it's a first degree equation. I'm going to add 5n to both sides. So I get 11n minus 24 equals negative 24. I'll add 24 to both sides and I get 11n equals 0. Divide both sides by 11 and I get n equals, let's see, hang on here. N equals 0. All that for nothing. We good?
Yes, on my end.
Let's check our work. Okay, let's check our work on this. So let's go back to the original. Let's see. See, that was a plus and that was a minus. All right, I think. So if n is 0, we have 0 plus 8/3 equals, oops, wait a second. I copied this wrong. Pretty sure that's a minus. Yeah, okay. So then we've got negative 8 over negative 3. And negative divided by negative is positive. So it checks. All right. Well, that's all I've got for you today. I'll be back at 1:15 with an office hour. We'll go ahead and stop the recording.